Number 36, graph the inequality, and we've been given x minus y is greater than negative 4. And for the purposes of graphing, let's pretend that instead of an inequality, we were given an equal sign. Sometimes people see the inequality sign and they get a little spooked. They're not sure what exactly to do. So let's pretend that instead of an inequality, we were given x minus y is equal to negative 4. And how would you graph this line? How would you graph this equation? Well, we could do one of two things. We could either find our x and y intercepts by creating a t-table, or we could simply put this into y equals mx plus b, and I think I'll do that here. So let's subtract x from both sides. That'll leave us with negative y is equal to negative x minus 4. And if we want to solve for y, meaning we want a positive y all by itself, let's go ahead and multiply our whole equation by negative 1 so that we can change all of the signs. So we have y equals now positive x plus 4. And now, how would we graph this line now that it's in y equals mx plus b? Well, we know the first thing we have to do is plot the y-intercept, which is b, so positive 4. And from there, what we're going to do is use the slope, which in this case is 1 over 1, to find the next point. So we'll go up 1 unit and over 1 unit to the next point. And now that we're going to connect the points here to actually create the line, we do have to go back and pay attention to what kind of an inequality we were given, because recall from class, if your inequality is less than or equal to or greater than or equal to, you have to graph with a solid line, and if you're simply given a less than or greater than, you have to graph with a dotted or dashed line. And in number 36 here, because we were given an inequality that was greater than, we're going to connect these 2 points with a dashed line. All right, so there we have the line. And now, because it's an inequality, recall that we have to shade on one side of this line. We're either going to shade above the line or below the line. And to determine which side of the line to shade on, we have to use a test point. And we can use any point to test so long as the point we choose does not lie on the graph itself. And whenever the opportunity arises to use the test point 0, 0, I always use 0, 0, the origin, because zeros are really easy to work with. In this case, we can clearly see that our line does not go through 0, 0, so let's use it. So we're going to test 0, 0, and we're going to plug this test point back in to our original inequality to see if we get a true or false statement. All right, so we're going to plug in x and y at the same time. So we're going to have 0 minus 0 is greater than negative 4. Well, 0 minus 0 is just 0, greater than negative 4. Is this a true statement? Is 0 greater than negative 4? Yeah, it sure is, right? 0 is bigger than negative 4. And so, because the point that we chose to test was below the line and we got a true statement, that means we could have chosen any point below this line, plugged it into the original inequality, and we would have had a true statement. And we shade on the side of the line where the points, when you plug them into the inequality, make the inequality true. So because our point was below the line and we plugged it in, got a true statement, we shade on this side of the line where the test point came from. If we would have chosen a point above the line, any point above the line, and plugged it in, we would have gotten a false statement. We don't shade on the false side of a line, we only shade on a true side. So if we plug in a point from above this line and get a false statement, we know we're going to shade on the opposite side. All right, but number 36, there's the graph of our inequality.